welcome to the analytical part of the class where we'll be doing labs on Wednesdays. I'll be posting videos on Wednesday. And the first homework assignment today is up on D2L, and it's about species accumulation, doing basic calculations, and making graphs in R. So homework 1 is going to use the data that we collected on Monday during the field portion of the course. And we're going to be using the data from Fort Ellis and from Highlight. And if you, just to refresh your memory, remember that we went out to the Fort Ellis Research Farm and measured and recorded richness and presence-absence of weeds in agricultural fields that were managed differently and rotated differently. In Highlight, we set out the modified Whittaker plot, and we'll also be using a data set which we collected last year during this course on circles and squares in Highlight, where we have the different frame sizes and frame shapes. So homework 1 is on D2L. All of it is in R. One of the best web resources that I've found out there is this web resource from Dave Roberts in the Department of Ecology at MSU. And I'll show you that quickly. The URL is at the top, and you'll see that there's an introduction for ecologists to R. And then there are 3 labs at the beginning that show you how to load vegetation data, load site and environmental data and make simple graphic summaries, and how to produce tables. All those will be helpful. And now I'm going to go through step by step through the homework by first going over to R. So I opened R, just like we did during the field course when we practiced. And the first thing to do is to set my working directory, so know where I put my data, and open that up with the script in there. So on a Windows machine, you can find change directory under file, or you can use the command set working directory. You can use the command set working directory on a Mac or any version or any operating system in the command console. On a Mac, you can find it under miscellaneous, and the shortcut is Command D, and that's what I tend to use. So I'm just going to press Command D, and it'll open it up, and I know that I'm going to go over here and find my data, homework 1, and I see that I can see most things in here, the homework script, the question, so I know I'm in the right directory, and I see all the data files. So I'm going to open that up, and you see now at the top right here it's set to where my data is. So you should always be able to see that and be able to check. So to the homework. So the objective of the homework is to analyze our nested plot data that we collected, evaluate if mean species richness differed between different shapes and different frames shapes and Highlight, and then create species accumulation curves for the modified Whittaker plot up in Highlight in the natural vegetation setting, and then we want to interpret and discuss our results. So we'll just skip down here. So to question 1. So question 1 asks, using the nested data frame we collected at the Fort Ellis farm, calculate and plot species accumulation curves for the different treatments. And we added in data from rectangular plots, even though we didn't do the rectangular plots at Fort Ellis. And so we'll be calculating species accumulation curves and drawing species accumulation curves for circles, rectangles, and squares. So back over to R, and then I'm going to open the script. You can do this in multiple ways. You can either go to open document in Windows or just press Command O, or I think in Windows it might be called Open Script. Either way, I'm going to just say Command O, and I'm going to go to this script, Homework 1 script. I'm going to open it up. And you'll remember the pound sign indicates just text that shouldn't be viewed as a command. So it gives you, there's some basic information there at the top you can see. And I've tried to be verbose in annotating the code here so that we know what's going on. But the first thing we need to do is load the data file from Mount Ellis. So that's done by using this read table or read.csv command. In this case, the data was saved as a comma separated variable, a CSV file, which is a type of text file. So I'm going to read that command in. The data files are all on D2L. You can find them. Make sure they're in your working directory when you call them up. And I'm going to read it by pressing command. I'm going to execute the command by pressing Command Enter on a Mac or Control R on a PC. And that read and executed the file here in the R console. You can see I got no errors. And now if I press FE, it will show me the data. So it's difficult to view the data, so I would like to see just the basic names of the columns, because the data here is organized into a matrix where rows are observations and columns are richness or species. And then one of our response variables, and we can see that by executing the names command, which we did on the first day. And you can see we have treatment, area, which corresponds to the area of the quadrat or circle, shape, which would be circle, square, or rectangle, and the number of species we found in each one of those plots. So I'm going to quickly move back to my script. In Windows, you can do that by pressing Command 2, and it'll always take you to your script. And I'm going to check out the dimensions of this. The dimensions refers to the size of the matrix. So we have 189 rows, or 189 observations, and 4 columns, which correspond to the 4 names up on the command line above. So when you use a $sign in R, it expects that after the object you'll be referring to a column name, so we can see what treatment looks like and the unique levels. So remember, we have a lentil rotation that's terminated with herbicides, lentil chemical, we have lentil graze, and lentil tilled organic. And these are all in rotations with winter wheat, if you remember. And we can see these levels for the different ones. We have circles, rectangles, squares. And if we'd like to see for area, we can just add, since it's numeric, we can just add unique, which will show us all the unique commands, or all the unique levels. And you can see there are all our different sizes of frames. So the question 1 asks us to plot a species accumulation curve with richness on the y-axis and the frame area on the x-axis for each one of the treatment variables and for the sizes. So there are many ways to approach this in R, and I'm just using a very simple way here so you hopefully understand what I'm doing with the data. So first of all, we would like to separate things out by treatment, right? Because we want to have a line or a curve for each one of the treatments and each one of the frame shapes. So the first thing I did here was to use the subset command to subset everything that has a treatment level that equals the lentil tilled organic. And that's in the blue highlighted right there, and I'm just going to execute that. And if you go look at your line, you see I got no errors, nothing in red, and that now we have a subset of the data set called FE, an object called FEOT, which is the data set where everything is subsetted to lentil tilled organic. So now we have the lentil tilled organic treatment, and now we would like to separate those lines into squares, circles, and rectangles. And I'm doing this just by subsetting this FEOT, which is Fort Ellis organic tilled, is kind of how I coded it or wrote it out. And then I just added here an S, a C, or an R for circle, squared, and rectangles, and separated out all those. So I'll execute those three command lines using subset. So the context of, or the syntax of subset is basically, I'm telling it to subset the Fort Ellis organic till data and give me only Fort Ellis organic till data when the shape of equals, in this instance, rectangle where I'm highlighting. So now I have all these separated by each of the individual treatments. So now I can see lentil tilled organic, I have know the area, I can see the shape, and I can see the richness. So now we need to calculate a mean for each one of these. We need one number for each one of the areas. And a simple way to do that is to use this command here called tapply, which stands for table apply. And remember, if you want to see the help, just press question mark and type the command. There we can see all the different ways you can use table apply, and which are extensive. And this is the R help. There's always examples at the bottom, which are often quite helpful. So what we're doing here, the syntax of this command line is to this table, which is FEOTS, so the Fort Ellis organic tilled squares, the richness of those, calculate the mean for all unique values of the area. So I'm going to execute all three of these command lines at once. They all worked fine. I got no errors. And now we can look at each one of these individuals by highlighting and calling it up. And you can see that all the plot sizes are labeled in increasing order by the number of species which we recorded in them. So we took the mean of all these plot sizes here for the three replicates when we had in organic. For example, lentil tilled organic with an area of 0.1, a rectangle, had no species. And then the other one is this here, lentil tilled organic, no species. Lentil tilled organic, no species. So we have that, that's why it equals 0. We took the mean of that and for each one of those. So now what we would like to do is plot our species accumulation curve by increasing plot size. So I had to be a little bit tricky here because I know that my unique names for OTR richness correspond to the area. I'll just call that up, and you can see there they are right there. They correspond to those names at the top, and that OT rich right here corresponds to the richness of the average of each one of those. So I'm just going to go ahead and execute this command line, which is a plot command. So the syntax is plot, the X variable, the Y variable. I told it to do the type, which is both, and then I put these different labels on here. So I'm going to execute that command, and you can see the graphic window just popped right up and put the first one on there. But I know I need to add the other two as well. But instead of using the plot command again, which always initiates creating a new plot, I'm using here just the points command because I would like it to add these points. And by using type B here, it refers to both for B, which will put lines between the points. If you use just type L, it will be lines. If you use type P, it will just be points. And I colored here, and you can see there's two ways here of adding colors. You can say color based on a number, or you can say color green like this. So I'm going to add these two to the graphic, and you can see I plotted my species accumulation curves for organic tilled. So basically, we just have to repeat the same code for lentils grazed. You can see we added it there. And then down here at the bottom it says we forgot to add this name. So I'm just actually going to take it from there and copy it up here. And you guys can play around with all this kind of stuff. And I'm going to add it in right here. So now I can go rerun this again by highlighting it, running it all. And now we have our organic graze treatment. So we've done that for 2 of the treatments. Remember, there's also the chemical treatment, which I've put that code in right here. You can repeat it again. You can see we get it for all 3. So now, be sure when you're doing your homework to add the correct titles and label axes by playing around. All the code wasn't necessarily made just to finish the homework problems. So that covers plotting and subsetting and taking the means of each one of these. I hope it's clear. And so we'll move on to the second part of question 1, which was to calculate the richness for the mean and the richness for each of the, let's go back to the homework real quick. So you can evaluate whether there's mean species. The second part of the question is to evaluate, is there a visual difference in mean richness between the frame shapes for 1, 5, and 10? So then, and you can see how to do that here by substituting in, by taking the standard deviations of the richness and looking at the different values. So I hope that's pretty clear. You can print these off yourself right here. Just pull over the data right there. There's the means and the standard deviations for both of them and all the sizes, so you can evaluate and answer that question. So I'll move on to question number 2, and that's going to actually use some circle square data that we had from last year from Highlight, and it asked a similar question, and this data was collected in a similar spot as to where we did our modified Whittaker plot. And the question 2 is calculate the mean number of species and the standard deviation for each plot and shape size using the Highlight nested data. And you'll want to fill in this table right here. You're going to have to add more rows to the table, just to be clear, and all the way down in all the combinations, adding the shape of the frame, the mean number of species that occurred in it, and then the standard deviation of that richness, or that mean number of species. So to do that, we'll read in the data like we did before. You can see I got no error, switch it over, and that the names of the columns in this case are area, shape, and richness. And so we want to do it for each one of these. So you can calculate, you can subset and calculate just like we did before. You can see what the data looks like. And so remember that we have unique combinations of area and unique plot size shapes. So we can do that with the T command, with the square. So here we just subset again like we did before into circles and squares. So we separated the square data by shape and the area by shape so that we can call these up now, and we see we have all the square data, and we have all the different shape frame sizes there. That second command we don't necessarily need. And then again, we're just going to execute this table apply command to calculate the mean based on the unique levels of C here, which are the areas for the circles and the areas for the shapes. To calculate the standard deviation, we just substitute standard deviation for mean in this command line. So now you should be able to do all of table 2 or all of question 2 and fill in the table. So question 3 can be answered using what the data as we calculated it in question 2, or we can do it in a fashion below. So question 3 is use the mean and standard deviation of species richness for the 1 meter squared highlight circles and squares, and answer, does species richness differ between the circles and the squares? So there's lots of ways you can do this. So I'll show you how to use box plot like we did before. So if you'll remember, our data set here is called Highlight HD, and I would like to see a box plot of the richness by area plus shape. You can see here we have the area first, followed by the shape of the square. You can think about how to interpret this and how it's easy. You can see the linear trends and the species accumulation curves. Spend some time looking at it. So I tweaked it just a bit so it was easier to see. I wanted just one letter here. I'm using the same data, and then I use this LAS3, which you can look up under box plot, but it basically turns the axis labels in different directions, and I called it up again to see that. So this time I shortened the names down here to just C and S, and then here I tweaked it again by putting the shape in front of area, so that it'll look for shape first, then area. So now, to answer your question, just look over at the far right over here in this area. You can see circles at 1 meter and squares at 1 meter next to each other. Alternatively, we can do it like this. So we would like to just subset the circles and squares data where the area equals 1 based on this highlighted command line like this. So I got no error, and I'm just going to type into the main console s.c.1, and you can see there it is. There's our circle and square data. We'll go back over to the script, and now I'm going to make a linear model. I'm going to make a mathematical formalization of the two by using this, which is linear model, and I want to predict richness based on shape. And I'm going to save that as object model. So here we go. I called up object model. The first time I accidentally didn't give it the whole command line, so it did. I got an error, but the second time it ran fine. Just see it again. And now I have this linear model of the relationship between richness in response to circles and squares. So what we've got here is, this is y equals mx plus b. So we know that the slope of the line is the same, but the mean response differs. So this intercept here is one of the two, and the intercept of one of the two shapes. So it would be circle because square is the only one left here. So circle had an intercept of 13.7 species per meter squared, and square had 13.75 minus the 1.4. That's how to interpret that. And then we can test if there was really a significant difference by doing a simple F-test or analysis of variance, and we could see that the probability that they differ from each other is 0.3. So you can interpret that and fill in the rest of question 3. So I'll move on to question 4. And question 4 is calculate the cumulative species richness for all these plot sizes. You're going to want to fill it into this table right here, and this is from the Whittaker plot that we did up in highlight. You'll remember that there were 10 5x2s, 2 2x5s, 1 5x20, and 1 20x50. So I'll go back to R and I'll call that up. Go down here to question 4. So the data for this question is highlight Whittaker1.csv, and I called the object MW for modified Whittaker. And here we can see what the data looks like. So there's the richness for each one of those by the area size of the plot. So we're pretty close to being able to plot our species accumulation curve and fill in all these values. But the first thing we need to do is take the mean richness for all of the smallest plot sizes. Here I do it here. I first subset it by area, and then I took the mean. This time I just used the mean command instead of the table apply command because I just had a single vector. You can see that I executed the command. So we know that the average is 12.27, and that here's the standard deviation. You can do that the same way. And so now we need to do that for the medium-sized plots. It's really done just the same way. There's the medium-sized plots, so the same thing, we subset them out. So now you should be able to fill in all the information for question 4. And then the last question, question 5, is to plot a species accumulation curve. So you can find the data from up there and look, you should check my data, but I made this vector richness by doing something here called by concatenating this vector. So C stands for concatenating. And I'm going to concatenate, which means to push all put together. First I'm going to take the mean here, and then we know the mean of the larger sizes, and we can see that simply by calling up this, just the data here, the modified Whittaker. You can see there's the richness, and there's 1 for each one of those. We calculated this mean, we calculated this mean, and now we need to add in these bits right here. We've done that by taking, again, just the mean of richness, 17 for the 2 2x5s and the other ones here. And then we concatenated the sizes together, so now we can view richness here after it's saved. Oh, I gotta execute the command first. Executed the command, no error. And so now we can go and I can highlight just richness and call it up. You can see there's the vector that we concatenated. Now we'll do the same thing with area. We can call up area. We can see we have the numbers there. Now they're equal. So now we can just plot both type. We can plot them and we get this graphic. So the way I save graphics usually, you can resize them however you want, make them. Usually the suggestion is equal or a square sized box to present the data, which could be something like that perhaps. But you could depends on what you want, how it looks better, and we'll keep working on this as the class goes. Then what I usually do is say, while I'm highlighted on this box, I go and say File, Save As. And in R, on a Mac, it automatically saves it as a PDF file that you can then edit in a lot of different programs. So you can save that, and then you can insert that right into your report by saying File, Insert into the Word document that you use. So that should cover all 5 questions of this homework. I hope it's clear. Review the Intro to R for Ecologists from Dave Roberts, and I'll put a link up to that on the website. And ask us any questions you have about the homework. Good luck.